Physics students, good morning. I'm Mr. Fugit here. If you're watching this video, this is designed to walk through group problem 4A. And so this is where we are pushing an object on flat ground that has some friction involved, and we're looking for the coefficient of friction. So we're going to spend just a few minutes kind of setting up what we're going to be doing in this group problem today. This is a day that I'm not here for you, but I wanted to make this video for you all as a way to kind of help you get started on the problem. So it says this: I have finally received my order from Acme Co. I have a project I've been working on for years to catch that lousy Roadrunner. Great show. All I need is to get the gear over to the road and set it up. The gear is in a box of mass 55 kilograms. I'm not a bodybuilder or anything, as you can tell, so I'm just going to push it there, not carry it. Takes a lot of effort though. I have to push with 230 newtons, about 50 pounds, just to keep this thing moving. I'm barely able to keep it moving, so it's traveling at a constant velocity that's pretty small. I wonder how rough the box and the ground are, so I want to know the coefficient of friction. That's what we're going to try and solve here. Now this problem is going to be very similar to the calcs problem that we solved previously in class. So that's a really good resource for you to look at. That being said, let's look at the two things that we're always going to do. Start with the free body diagram and then use that as a way to look at Newton's second law. So there are four forces here. We have gravity acting down on the box. We also have a normal force acting up on the box. That's a result of contact between the box and the ground. We're also, let's say, pushing the box, not at an angle, just on flat ground. And as I push, friction is resisting the motion of our box. Okay? There are four forces all in one direction. Now, we're going to take those and plug them in to Newton's second law. So, sum of forces is equal to mass times acceleration. Now we're going to break that down into the two directions that we have. Okay? The sum of forces in the x is equal to mass times acceleration in the x, and the same in the y direction. Sum of forces in the y is equal to mass times acceleration in the y. Now, once we're here, remember we're looking for a coefficient of friction. And right now, it's going to seem a little bit confusing because that doesn't show up anywhere in the problem statement. But if we continue reading what's there, we draw our free body diagram, we write out Newton's second law. Let's start to put these forces into our equation for Newton's second law. In the x direction, I'm going to call to the right the positive x and up the positive y. So in the x direction, we have two forces. Our push force, which we'll say is positive, and we'll subtract our force of friction because it's going opposite of our motion. Now, we know the mass of our object, but we don't really know its acceleration. But if we look back at our problem statement, it says we're going at a constant velocity. And if you remember, that's an important phrase. Constant velocity just means no acceleration. And what that tells me is that my push force, if I add this over, is equal to my force of friction. And thankfully, we know our push force. That's the 230 newtons we were told at the beginning of our problem. So that's one important relationship we're eventually going to need. Right? The second, in the y direction, we know our normal force is pointed up, Fn. Our force of gravity is pointed down, Fg. Now ideally, as we push our box, it's not going to be moving vertically, and so our acceleration in the y direction is also going to be 0. And that tells us that Fn is equal to Fg. So this is a good starting point for what we're going to be doing in this problem. Remember, we need to find our coefficient of friction. And that coefficient of friction shows up in one place. Our equation for the frictional force. Our coefficient, mu sub k, times the normal force, Fn. You'll have enough information to solve for your frictional force and your normal force. We're going to use those to eventually find our coefficient. And remember, it should be in a range of 0 to about 1.5. Okay? So hopefully when you're going to get an answer somewhere within that range. Okay? There's going to be a key for this problem as you're working it in class up here at the front. So come up and check. That's going to be a good way for you to work through the problem. Make sure you're on the right track. And best of luck and enjoy your day.